So today we are still working on the second module of the seismic earthquake engineering discipline. And I will remind you in the first part of our lecture main points, the main paragraphs that we have already discussed. So first of all, we have considered the issue: how can we reduce the losses due to the earthquakes? And we know three main ways. So first, it is the preparatory works with the with the inhabitants. Next, it's forecasting of the earthquake, and the third one, our way, it's the earthquake resistant construction, and it is our way. So next question that we have analyzed, it is seismic risk, and we know that seismic risk is the result of multiplication of seismic hazard on seismic vulnerability. And we already know that we have nothing to do with seismic hazard, because seismic hazard is an input data for us, but seismic vulnerability is part of our work. So we, as a future designers, will work with seismic vulnerability. But nevertheless, we had to analyze the ways of definition of seismic hazard, and we know that definition of seismic hazard consists of two main parts. So first part, it is define the seismic hazard of the region, and second step is define the seismic hazard of the exact construction site within the region that we have analyzed previously. So first of all, to make the first step, we have to use, in our case, DBN or Eurocode or norms in Austria or ACI in United States. But depending on the country where you will design your building, you have to use the local building codes to define the seismic hazard of local region. And in our case, we have DBN. According to DBN, we have three main maps, according to which we can define the seismic hazard for the exact construction, exact region. So we have three main maps. Also, in Annex B to DBN, we have tables according to which we can also define the seismicity of the region. The main idea of definition is based on the probability of the certain earthquake and the certain location. For example, when we're considering map A, we are talking about the strongest earthquake once per 500 years. When we are talking about map B, in this case, we have to consider the strongest earthquake once per 1,000 years. And when we're talking about map C, it is the strongest earthquake one per 5,000 years. If we will make these work, for example, for in other countries, we can use Global Site. It's an international software company which develops various products for calculation, for analysis, and some of them are online. Uh, you can use them online, and for this operation you can use it 5 times for free. So it also can help you in definition of the seismic hazard of the exact region. So next point is to define the map according to which we will define the exact seismicity for the region, and it depends on the height of the building and the consequence class of the building. So all consequence class, but with the height less than 73.5 meters, we will define according to map A. All the buildings with the seismicity with the height of more than 73.5 meters will be defined according to map B. And when we're talking about map C, it is for unique buildings with increased danger. And in this case, we will use map C. Also, we have map A0. This map means that we can define the seismicity for this regions for weak earthquakes or even for project for the design earthquakes, but for the consequence class buildings CC1 without the presence, uh, continuous presence of the people at that site. Next step is to define the seismicity of the exact site is to make a seismic seismic microzoning. It is a process of definition of the properties of the soils on the exact construction site, but this work is expensive enough. So, in other cases, for like CC1 or CC2 consequence class buildings, we can use also this table. And this table shows us that according to the category of soils, we know that there are four main categories of soils. The best one is the first one, the worst is the fourth category of soils. And according to these categories of soils, we can define which multiplication or reduction of seismic impact will be at this construction site, at certain construction site. For example, we have to know that all the maps of global seismic zoning is developed for all the maps are developed for the second category of soils. But when we have in our situation, for example, third category of soils, and according to map A, we have 6 points of seismicity in our case. For the third category of soils, we have to add additional point, and we will calculate at this exact construction site on 7 points seismicity. But if in the same situation we have category of first category of soils, in that case we can reduce on 1 point the seismicity of the construction site. Next issue that we have analyzed is seismically adverse areas, and we know that there is a list of areas which are located in the places with the possible occurrence of tectonic faults on the surface, with the steepness of more than 15 degrees, with talus, landslides, karst, erosion, mike works. Undermined territories also located on the areas of possible meltdowns, avalanches, and even tsunami hazardous areas. And also seismically adverse areas consist the categories with fourth category of soils according to the seismic properties. So, by the way, when we're talking about the tsunami hazard of Black Sea, we have to know that according to the analysis of the potential of tsunami waves in Black Sea, we have to know that in our area of Black Sea, we can get the tsunami with the height not more than 5 meters. So, and for the most part of Odessa territory, 5 meters means nothing because the the main part of the city is higher than the level of the sea on 50 meters. But all the seashore territories are under the hazard of potential attack of tsunamis with the height of like 5 meters. But we don't have any code, any building code in Ukraine according to which we have to take into account the impact of tsunamis. Next issue that I want to discuss with you, it is that we have discussed with you. It was the level of seismic impact, and we know that during the calculation we have to analyze three main levels of impacts: design earthquake, weak earthquake, and maximum design earthquake. All these levels corresponds to the exact effects on the building after such earthquakes. Because after weak earthquake, we can the ability for immediate occupancy of this building. Right after the earthquake. When we're talking about the design earthquake, we can return the people, their activities inside of the building after various levels of repair. And after the maximum design earthquake, it is impossible to renovate or reconstruct this building, but this building has to protect the people from the progressive collapse. This building will be demolished, dismantled after the earthquake, but nevertheless, the people inside of it had to be protected from the earthquake effects. Next, we have analyzed three main methods of calculation on seismic effects. First, it was spectral method, and we almost completely analyzed this method. Second one was devoted to the second part of this course will be devoted to the dynamical method, and third part of this, not course, this lecture will be devoted to the nonlinear static method of calculation. So here are the calculation schemes. Here is the basic formula for the spectral method of calculation, and it is, as you see, it is based completely on the second Newton's law. But when we're comparing seismic effects and with regular effects, we have to admit that seismic effects have their certain specific, and this specific can be accounted by using the coefficient k. And in our case, this formula, according to our DBN, can be transformed in these two formulas, which describes absolutely the same. But in this case, force marked with the letter F, and in our case, seismic force marked as letter S with the indexes Ki. And I will remind you what does those indexes means. Also, we have coefficient K1, which includes and describes nonlinear behavior of the building. K2 includes the responsibility coefficient. K3 includes the floor amount, additional effect of floor amount. Q with K index, it's mass weight. So it's the same mass as you know, but in this calculation we include it as a mass which is corresponding to the exact weight which affects all the slab. And A with zero index, it's a spectral acceleration. K soil, it's a soil coefficient which includes also the additional effects of the earthquake, and it describes the collaboration, is it possible to say in this way, the joint behavior of the building and the soils on which it is located. And almost final coefficient beta, it's a spectral coefficient. The presence of this coefficient in that formula, in this method, gave the name of this method, because spectral method of calculation is called in this way because of this coefficient. And this coefficient describes the additional multiplication, additional seismic effect because of its specific impacts. And these coefficients are the values of these coefficients are based on the soils category of soils by seismic properties, and also they are based on the duration of the vibration. So it's based on the period or on the frequency of vibration of the building. So, and based on these two parameters, soils and period, we can define the multiplication effect of this coefficient. For example, if we have a stiff building with the period, for example, 0.4 seconds, in this case, this coefficient will be equal to 2.5. But when we have a flexible building with the period, for example, 2.5 seconds, in this case, we will get the value of this coefficient 0.8. It will be like reduction coefficient. Also, we have eta Ki with Ki index. It's a coefficient which describes the part of the mass of the building which takes part in the vibration process. And here is the way of transformation of our basic formula of the second law of the Newton's second law to the formula which we can find at our DBN. And now I will remind you how can we define these indexes Ki. So, for example, when we are considering the building, for example, with 4 stories, 4 floors, we can assume that all the slabs can be modeled like masses, and all the columns can be joint behavior of all columns can be collected at one and be modeled like one rod. And for this case, we have 4 forms of vibration, and for each form, we have the vibration of 4 masses: 1, 2, 3, 4. So, index I means it's first form, second form, third form, and fourth form. Index K means first mass, second mass, third mass, and fourth mass. Тобто, якщо ми будемо розглядати з вами коефіцієнти S, які йдуть при літері S, тобто КІ, вони мають наступне значення. І це номер форми коливань, бо один 4-масовий стрижень може коливатися на 4 способи. І перша форма, друга форма, третя, четверта форма. І К літера, вона позначає номер маси. Перша маса, друга маса, третя маса, четверта маса. І ви бачите, що маса К тут є, і К враховується також тут і тут. Ми казали, що цей коефіцієнт враховує ту частину маси, яка приймає участь у коливальному процесі. Q з індексом К, вона позначає величину навантаження, яке буде преобразовано у маси, і таким чином 16 сейсмічних сил ми повинні визначити для кожного вузла, для кожної форми коливань. So, in this case, when we are considering 4-mass rod, we have to make a definition of 16 seismic forces. For example, for this building, we will have form number 2, and in this direction to the right, we will get the seismic force, which means that it's mass number 1, form number 2. It will be S1, 2. For this, S2, 2. For this, it will be S3, 2, and for this, S4, 2. All these values will be defined according to the calculation which we have analyzed previously. Next way that we have to know that when we are calculating our building on seismic forces according to the spectral method, we have to take into account as a minimum 3 main mutually orthogonal directions of seismic forces. То коли ми з вами розраховуємо за спектральним методом будівлю, ми з вами повинні враховувати, що до нас землетрус приходить до відповідно до як мінімум за 3 взаємно перпендикулярними, з 3 взаємно ортогональними напрямками по X, по Y та по Z. Це мінімальна кількість, тобто менше не може бути, а додатково ми можемо під час розрахунку визначити найгірший напрямок і відповідно до нього виконати розрахунок. Тобто, according to the result of calculation, we can also define additional 1 or 2 or even more directions of impact of seismic impacts and take them into account during the calculation. The next important parameter that we have also to discuss, it is the displacement, which is described in the best way by the interstory drift. Because when we're talking only about the displacement, nothing to do with the displacement, because displacement 1 meter during the earthquake, is it good or is it bad? Тобто, наскільки погано чи добре, якщо ми під час землетрусу реєструємо зміщення будівлі 1 метр. Це добре чи це погано? Бо є показник, який характеризує переміщення, а є відносне переміщення. І саме відносне переміщення для нас уявляє суттєвий інтерес. Бо якщо if we will consider only 1 meter displacement, because 1 meter is too much for the two-story building, but 1 meter is absolutely okay for the, for example, 30-story building. Тобто переміщення вверху для двоповерхової будівлі це повне руйнування, розуміється під цим. А якщо в нас 30-поверхова будівля, то під час землетрусу, якщо верхівка зміщується на 1 метр, то нічого страшного з цією будівлею не буде. Тому нас інтересує не абсолютна величина зміщення верху, а для нас інтерес уявляє собою інтерсторі дріфт, міжповерховий перекіс, тобто відношення переміщення верху катого поверху, верх катого поверху мінус переміщення низу катого поверху і поділене на висоту. Саме відносна величина для нас появляє собою інтерес. So, if we will analyze the interstory drift, the absolute interest for us is light into the ratio, not the absolute value of UK, but the ratio between the top of the displacement of the top minus displacement of the bottom divided on the height of the exact floor. And these parameters shows us this parameter is the criteria of the behavior of building during the earthquake. Саме цей параметр, він є дуже важливим критерієм, який демонструє нам статус будівлі під час землетрусу. Тобто, чи є в нас якийсь резерв, чи в нас немає резерву, чи будівля запроєктована з дефіцитом сейсмостійкості. So, this value shows us if we have something reserved for the earthquake or we have lack of seismic resistance for this exact building. So that is why we have this formula, not the formula, these values, which shows us the behavior of the building during the earthquake, during the weak earthquake, design earthquake, and maximum design earthquake. Тобто є в нас така таблиця, яка нам демонструє, яким чином буде поводити себе наша будівля під час землетрусу, тобто які граничні показники деформування будівлі під час землетрусу. For example, if we will take into consideration, for example, this flat slab without diaphragm and chorus. Наприклад, якщо ми з вами візьмемо залізобетонний безрівний каркас без діафрагм та ядер жорсткості, то при слабкому землетрусі в нас перекіс складає 0,067. Якщо в нас висота поверху, наприклад, 3 метри, 0,067 помножаємо на 3 метри 3000 мм, то в нас гранична величина зміщення складе близько 20 мм. So, if we will take into consideration a flat slab without diaphragms and cores, for this structural scheme, during the weak earthquake, we can get not more than 20 millimeters. So, in the most deformated floor, in the most deformated story, we can only limit 20 millimeters. So, if our displacement is less than 20 millimeters, then it is okay for our building to substitute to withstand the weak earthquake. Тобто, якщо ми з вами розглядаємо цю ситуацію розрахункову, то що ми з вами побачимо? Якщо ми розраховуємо будівлю і під час розрахунку на слабкий землетрус у нас відбувається переміщення у найбільш деформованому поверсі менше за 20 мм на поверх, то це свідчить про те, що все окей, наша споруда здатна протистояти слабкому землетрусу. Потім на ту саму будівлю ми вже прикладаємо проектний землетрус, більша величина. Та сама конструктивна система. So, next step, we will calculate our scheme on the design earthquake. We will analyze it, and the limit value of the interstory drift will be 0.012 multiplied on 3,000. It will give us 36 millimeters. So, if our building during the design earthquake, will get the displacement more than 36 millimeters, it is not okay for this building, because the limit value of the displacement have been overestimated or have перебільшена. Зараз. Wait a minute. Вилетіло слово з голови. Exceeded. So, if our displacement with more than 36 millimeters, then it exceeds and exceeded, this value exceeded. That means that our structural scheme has not enough rigidity and load-bearing capacity to withstand the design earthquake. So that is why we have to make certain adaptations of the construction or structural scheme of the building to reduce this effect. So, and next, the maximum design earthquake, which we will perform based on the map C of global seismic zoning. And in this case, we have a limit 0.03. So, for the 3,000 millimeters height of the floor, the maximum displacement will be 90 millimeters. So, if our building during the earthquake gets the maximum design earthquake gets the displacement less than 90 millimeters, that means it's okay, it is safe for the people. But if during the calculation we will get more than 90 millimeters, that means that our building will be fallen down during the earthquake. So these rules were written by the blood of dead people. So, якщо ми будемо дивитися на ці величини, на ці норми, то вони написані людською кров'ю. Це є результати аналізу поведінки будівель. І якщо в нас під час максимального розрахункового землетрусу відбудеться перекіс менше, ніж 90 мм, то в нас будівля здатна вистояти під час землетрусу. Але якщо під час цього землетрусу, під час розрахунку на цей землетрус у нас відбудеться переміщення більше за 90 мм, то в нас така ситуація буде значити, що будівля не вистоїть землетрус. Тобто ці величини, вони... So these values, this kind of calculation is called performance-based seismic design. Такий розрахунок зветься розрахунок будівель, проєктування будівель, яке базується на поведінці під час землетрусів. Ось таке визначення. Performance-based seismic design. Okay, so next, so all these values were defined after the earthquakes, and based on these values, you have to analyze the behavior of your building according to weak earthquake, design earthquake, and maximum design earthquake. So, чи є якісь запитання по цій частині? Is everything clear, or you need an extra explanation? So next, so same case, same table, but in Ukrainian, and as I described you, same rule. So we have minimum displacement, which means uh, weak earthquake, and we also have we also have design earthquake, which means bigger displacement, because after this earthquake we can make the capital repair or the current repair of the building, and maximum design earthquake, according to which we will get the mm, complete destruction of the building after the earthquake. And one more slide I will give you. Second. We will see this slide and discuss it later, but nevertheless, I want to show these ideas to you even at this stage of this lecture. So, так. Зараз я модифікую цю таблицю. Таким чином. Так. So, and the main idea for these tables gives us the understanding of the current situation. So, we have three levels: immediate occupancy, in Ukrainian called weak earthquake or слабкий землетрус, і life safety рівень, який відповідає design earthquake, проектний землетрус, і є МРЗ, максимально розрахунковий землетрус, або попередження колапсу при землетрусі. І тобто ці три точки, вони характеризують поведінку будівлі на різних рівнях впливів. І після цього вже відбувається руйнування будівлі. So next method of calculation, which we also have to discuss, we have to analyze how in this method, in this calculation method, can we include all these forms. For example, this building has only 4 forms, but when we are calculating multi-story buildings, it's like 50,000 of masses, and it means that we can take into account all the else 50,000 of forms. But we have all these forms. According to each force, to each form, we have a resonance effect. But when we are calculating on seismic effects according to the spectral method, we have to admit that the worst part in this method is that we have to take into account all the forms. So one value of the internal force, you have to include 4 forms and resonances on 4 forms. This situation is impossible, but nevertheless, this is the worst part of this method. It is simple method, but nevertheless, has certain lacks, and it's like average temperature at the hospital. When somebody has 0 degrees and somebody has 40 degrees temperature, body temperature, and that means in common that everything is okay, but nothing is okay. Коли ми розглядаємо з вами спектральний метод, ми повинні розуміти, що при всіх своїх перевагах, що це простий метод, це зручний метод, він має суттєвий недолік, який полягає в тому, що ми, коли з вами, наприклад, розраховуємо чотирьохмасову систему, ми з вами повинні враховувати 4 форми коливань. І кожна форма, вона під кожною формою розуміється, що в нас відбувається резонанс по кожній з форм. І ми розуміємо, що одночасно не може статися резонанс по всіх 4 формах, але цей метод таке враховує. Потім ми врахували ці сили по цим резонансам по 4 і повинні їх врахувати у визначенні цих внутрішніх зусиль від цих 4 форм. Як воно враховується? Це корінь квадратний суми квадратів, тобто не враховуються і напрямки цих сил, не враховуються співвідношення цих сил. І проблема стає у тому, що це як середня температура по палаті, коли в одного температура 40, у другий вже 0 градусів, а в середньому по палаті все добре. І цей метод має такий певний недолік. Ще one more additional thing that we have also to take into account that when we are calculation a special form, a special structural scheme, we have to include that in special space we have the direction of seismic force like this, like this, like this, and to take into account the overall effects according to x, xy, xz, we have to make this part of calculation again sum of squares of sums and square root from sum of squares of each direction, which gives us the value of the internal force in our structural elements. Коли ми з вами виконуємо розрахунки у просторовій постановці, коли в нас сейсмічна сила, вона не тільки вздовж осі X, або осі Y, або осі Z, вона має якийсь просторовий вигляд, то тоді ми повинні враховувати усі складові, які є по осі X, по осі Y, по осі Z. І ось таким чином вони визначаються. One more additional effect that we have also taken into account called seismic moment. And this seismic moment takes its origin from the situation where we have the center rigidity and center of masses located on certain distance. And this gives to the lever arm, to the creation of the lever arm, which gives these torsional forms of vibration. Or in this case, you can see that all the walls are concentrated in the one part of the building, and here in this part of the building we don't have any rigid elements. That gives to this torsional vibration of the building. So, and also here we can see we can get the same situation. So and only one way we have to reduce this seismic moment is to make to make coincidence between center of masses and center of rigidity. In this case, we will get zero value of the lever arm, and it means if we have a lever arm which equals 0, we have moment which is also has a 0 value. Та величина, про яку та величина впливів, яку ми з вами зараз будемо проговорити, вона називається сейсмічний момент. І для того, щоб його врахувати, нам необхідно глобальну сейсмічну силу, що приходить на нашу будівлю, домножити на сейсмічне плечо. Сейсмічне плече, воно виникає як дистанція між центром маси та центром жорсткості. І зменшити цю величину ми можемо лише за рахунок того, коли у нас буде збігатися центр маси, центр жорсткості. Як чим далі одна величина від іншої, це центр маси від центру жорсткості, чим більше в нас плече, тим більше в нас буде сейсмічний момент, який ми повинні враховувати при проєктуванні. Also, we have additional model for the spectral method, and this model gives an opportunity to include the. Sorry, 1 second. So these. This part of spectral method gives an opportunity to take into account various special parameters of building. For example, if it's has a long duration of this building, in that case, when our building is really long, then running seismic wave will at the first part impact on this part of the frame, on this part, on this part, on this part. One by one, it will make an impact on each part of this building, and this effect of the running wave also have to be taken into account during the calculation. For the simple building, everything will be okay, but yeah, as you see in here, but in plane it will be the same displacement of these parts of these slabs. But when we're talking about this building, so by duration we will get additional such effects, and these effects are connected with the length of the seismic wave. So and these effects can be taken into account by also by the spectral method with additional coefficients. Here are those methods of calculation. Тобто, ще в нас є додатковий модуль, додатковий розрахунковий підхід відповідно до спектрального методу для будівель, які мають протяжність або певні особливості з нерегулярного розподілу жорсткості уздовж будівлі. І ці впливи вони враховуються різним способом за допомогою додаткових коефіцієнтів, і вони моделюють той ефект, коли в нас сейсмічна хвиля має певну довжину і будівля довга. І якщо будівля довга, то вона не уся цілком буде деформуватися під час землетрусу. В неї спочатку перша частина зазнає вплив, потім друга, потім третя. Тобто ефект бігучої хвилі уздовж будівлі призведе до того, що вона буде поступово деформуватися якось ось таким чином. І це необхідно також враховувати, щоб запроєктувати конструкції здатними до того, щоб витримати ці зусилля, що будуть виникати. Так, чи є якісь запитання по цій частині? Чи все зрозуміло? Добре, тоді зараз робимо паузу і повертаємось після перерви на другу пару.